Hey guys, this is my first quadcopter created using a Raspberry Pi Zero W. As you can see, I'm using a Raspberry Pi Zero W placed over here in all these wires, and this one has a Wi-Fi and a Bluetooth connection, connectivity setup, and also using a small SMPS, which would supply around 5 volts to the Pi. It has been rated for a maximum of 3 amps, and after checking over various forums and the specification, I found out that Raspberry Pi Zero W consumes around max of 1 amps, and as compared to a Pi 3 would consume around 2.5 to 3 amps. So I think this setup works fine. The SMPS, it would be powered from my 12 volts battery, which would be powering also the motors. Also, I'm using a Pi Zero camera. So just to let you know, please make sure the camera that you're using, the camera cable for a Pi 3, the cable is slightly different. It's wider as compared to a Pi Zero W. So also these are the wires which will be sending the signal to my ESC. The ESCs are rated for 30 amps. Make sure you are using the right ESCs because the motors would consume around a lot of current depending on the rating. They consume around 26 amps at maximum throttle. It would depend on the throttle, like how much current is being consumed. Since if you're building your first quadcopter, make sure you follow these things. Also, I'm using a Champion 5-inch propellers, 3 blade, and also a LiPo battery. So this is around 1800 mAh, 3S and 40C. So let me start. For this demonstration, I'll be using a small battery pack as currently I'm still working on this project. So this is a 18650 battery pack, which would be, it's rated for 11 volts, but it won't be supplying the maximum current required. So we'll just see how this works, and let's get started with the calibration. So basically this would be working on a node.js code. So the node.js code will be running on my server side, which will be my Raspberry Pi Zero W, and I would be controlling the same with the front-end application. Let's get started with the calibration. So just to make sure every ESC, the speed controller, can have their specific calibration style. This is another motor that I had first tried with. It's a cheap motor and a 30M ESC, but as you can see, the size is quite different. It's quite large. Um, yeah, okay, Simon K. So it has a different calibration procedure, and right now, let me just connect the battery to this. So, this is the T connector. So now different types of batteries can have different types of connector. Make sure you're using the right ones because they would be supplying a lot of amps of current. Trying yesterday outside, and we used some very low quality wires, and this was the result. So we actually burned the wires, and yeah, that was very dumb of us, but and it's pretty difficult to get those wires over here where I stay, so I guess it would be taking around some time to get the required wires and finish the setup with this battery. So let me first connect the battery, and you will hear a small beep. Make sure the terminals are correct. Okay, I think this is fine. So you can see my Pi has also powered up. Pi has now been powered up. So I will just open PuTTY and log in into my Raspberry Pi. So I have already entered the IP. The credentials are like by default are like Pi, and the password is Raspberry. Okay, we are now able to access the Pi, and I'll just change to the directory that is required and start my Raspberry Pi Node.js program. I would be controlling the quadcopter using this Node.js program that I have written. So I have already installed npm and node.js on my quad on my Raspberry Pi. Let us head back to the browser and turn on the local host. And yes, every ESC has a different calibration procedure as I had mentioned. So right now when I calibrate this, I would be pressing the keyboard key P over here, and you can see the calibration is currently false. So here I have created various buttons like a full screen mode, which would display the camera over the entire screen, calibration, which could be clicked or controlled with your keyboard. Kill power would be to reduce the motor powers in steps so that it would reduce and it would land properly. So it's like even I have created a signal strength signal to display over here. So if it runs out of the outside the Wi-Fi range, then it would just stop and after reducing the PWM gradually. And there are many more things like hover and lights, which is in progress. Cap the keys as WASD, which we gamers normally used to play, and also the up down arrow. So up down arrows are to move up and left and right and down, and WASD basically to turn, go forward or backwards, and take a left turn or a right turn. So these are the keyboard keys. Let me now complete the calibration. When I hit P over here, it would create some noise, give some beeps. So let us check it out. So when I press the P, you'll see it has been changed to true. So after all these beeps are done, it would be clear that the calibration has been completed. And now we can start with the code. So I would be pressing these buttons up and down arrow. Means let me start with up arrow, and we can see that the motors now begin to turn, and the speed will be also increased if the key up key is pressed. So let me start. Oh, I forgot to enable the flight mode. So I have created another button on the flight mode, which would enable the motors to turn actually. So let me press F and turn on the flight mode to true. And yes, so now let me start. So here we go. So this is at full throttle, but it would be reduced as my battery won't be supplying the required current. And let me get it down. So the camera mode is also present over there, and I can kill it using K, or I can reduce the speed over here. So now we have connected the propellers, and let me just quickly start the motors and give you a short demo. So I can vary the speed in steps, and which allows me greater control over the motors. Practically, this can be used by opening a URL on your laptop, and you won't have to use any other controllers and access it anywhere over the world after certain changes. So I'm currently developing this a bit further. We are yet to receive the new 12E WGYS, which would enable us to connect the high power battery, and also MPU 6050 gyroscope to help us align it more properly. So currently we have finished up to here, but further research is still on. So thanks for watching and have a nice day.